Hello, network engineers. Welcome to session 4 of the segment routing series. In this session, we are going to learn about adjacency SID. So let's start. By default, the prefix SID routes along the shortest path. The alternative path will not be used, which may cause congestion on the primary path. Therefore, adjacency SID is employed to bypass SPF and direct traffic to the longer path based on policies. The primary application of adjacency is of course traffic engineering. The another one would be a TILFA. So both of the use case we will be looking in detail in future videos. Label for adjacency SID will be allocated from dynamic range. This is the same range where LDP and BGP labels are being allocated, but this is partially true. If we define a static label, static index value for adjacency SID, then it will allocate the label from SRLB. Adjacency SID is also referred to as local segment, as this instruction are executed when traffic with the adjacency SID reaches the router that originates it. Then the router will carry out the instruction. So let's understand all this point on whiteboard. So we have P4 as a root router, P1 as a source router, and I have introduced P7 between P1 and P2 for ease of explanation. In this topology, as we can see, we have two paths. One is primary one according to SPF, which is shown via violet line. I hope this color is violet only. And we have secondary path, which is shown in black line. By default, cost is 10. And now let's say the link between P2 and P3 is already highly utilized. Let's say it is carrying traffic 70% of total link capacity. So if it is gig link, then it would be 700 Mbps. Now let's say the traffic behind P1 increases. According to the SPF rule, all increased traffic, P1 will put it on the primary path only. And let's say the link utilization between P2 and P3 is increased from 70 to 99%. And now we are facing packet loss. Meanwhile, the secondary path is idle and has the and this path has the capacity to carry more traffic. Maybe this path, let's say P5, is primary for some other P, but overall this path has some capacity to carry few more traffic. In this scenario, adjacency SID will come into the picture where on P1 we'll run a policy and divert some traffic on secondary path. So let's see how it will work. So we will create a policy. How to create a policy? We are going to learn in traffic engineering session. So we will create a policy in such a way that it will push list of label as follow. So first it will push 16,002, 16,002, and then it will push, let's say for this adjacency, the label allocated is 24,001. Then it will push 24,001, and then it will push 16,004. Now how it will work? P1 will send the traffic to P2. So P7 will pop 16,002 and send the traffic to P2. P2 will receive the traffic with this label stack 16,004 and 24,001. Upon receiving this label stack, P2 understand that is the one originate 24,001. So it will process it. Instead of following SPF, it will send the traffic to P5 and pop the adjacency SID. Now P5 will receive the label as 16,004 and P5 will send the traffic to P4 via SPF. So P6 will pop 16,004 and send the traffic to P4. So let's go back to our theory and let's read it again. By default, prefixed routes originate the shortest path. Yes, the alternate path will not be used, which may cause congestion on the primary link. As we can see, the link was 70% utilized. As traffic increase, this link blown up. The primary application is, so we have seen the example of traffic engineering. We will see the example of TILFA. We will see a use case where the adjacency SID will be allocated from SRLB, and we have, with the help of example, we have seen how adjacency SID works. So that is upper view of the adjacency SID. So let's demystify the working of adjacency SID and understand how adjacency SID is propagated in ISIS or segment routing domain. Two adjacency SID will be assigned for each ISIS neighbor. One is called protected and another one is non-FRR. By default, non-FRR label is allocated in ISIS database. Both the protected and non-FRR label will be installed in ISIS database once TILF is configured on the router. The protected label indicates that the backup path is already installed in safe table. So when traffic hits, when a primary link goes down, it will immediately divert the traffic to the backup link. The non-FRR label indicates that it will wait for SPF to run before installing the backup next stop in the safe table. Okay, so let's understand all this point in whiteboard. So let's say P2 is our calculating router. This link is our calculating link. So once we enable segment routing on P2, it will allocate two label per neighbor. So let's say for P2 gig 0002, there are two labels allocated. So let's say two labels are 24,002 and 24,003. So one would be a normal adjacency SID and another one is non-FRR adjacency SID. And then in ISIS database of P2, only non-FRR adjacency SID would be installed. So 24003 would be installed. It will carry few flags. So let's track the important one. So the first one would be F, which is 0, and it indicates whether this is IPv4 or IPv6. For ISIS running IPv6, another adjacency SID would be created with flag 1. And second one would be the B flag. So it indicates whether this is FRR or non-FRR. For non-FRR, B flag would be 0. Okay, and this LSP will be sent to all ISIS neighbor, and it would be propagated in all the ISIS domain. Okay, so let's go to the lab and see all this theory. So let's see. I can say gig 000 detail. Two labels are allocated. One is adjacency SID and another one is non-FRR. So if I'll open the ISIS LSP for P2, I'll see 24,003 would be copied in the LSP. So ISIS data bits P2 verbose. So towards P5, right? P5, this one. So here you can see adjacency SID 24,003 is copied, where F flag is 0, B flag is also 0. Apart from that, let me enable, let me show you one more thing. So it is not true that adjacency SID is always being allocated from dynamic range. it can be allocated from SRLB as well in case we define it statically. When we go to route ISO interface with 002 address for unicast adjacency SID index 4. So once I do that, so if I open ISIS database, I will see both adjacency SID, static as well as dynamic, would be copied to ISIS database. Video workflows. Sorry. So this is towards P5, and you can see both. These both are known as our adjacency SID. Because backup flag is 0. And let's see the ISIS database after enabling TILF as well. Router ISIS code. And let me enable it for a particular interface itself. /2 fast route per prefix fast route per prefix TILF. So commit. So if I check adjacency now, it will look a little bit different, which we are going to understand in TILF section. So here you can see the backup stack as well. But here you can see 24002 is protected. Now we see the database. We do workflows. Where is P5? Toward P5, you can see the protected one with flag 1 is also copied in ISIS database to calculate TILFA calculations.